Over the name reactions now. Okay, so these are the name reactions which I will be telling you in today's lecture. That is the name reactions related to the carbonyl groups. It could be the Cannizaro's reaction, Aldol condensation, Claisen condensation, Perkins reaction, Gabriel phthalamide synthesis. So in total, how many name reactions we are going to focus? We are going to have a look for the for those 5 name reactions. 1, 2, 3, 4, 5. So 5 name reactions we will be covering in today's lecture. So let's first start with the Cannizaro's reaction. So what is this Cannizaro's reaction? Let's focus over it. Guys, if I am talking about the Cannizaro's reaction, this is a reaction of a carbonyl compound. Okay, here let me take an example. I have taken a formaldehyde. And here I am reacting this with another formaldehyde. So ultimately what will happen? Here I am having 2 formaldehydes, or I could be having any other kind of group. So when I am having such kind of carbonyl groups with no alpha hydrogen, so this is my carbonyl group. Okay, so this is a carbonyl containing compound, carbonyl containing group, and when in the presence of a base, when this reacts, there we will be getting the preparation of 2 products. One is going to be the formic acid, the another is going to be the CH3OH, that is alcohol. So the question is that how you are getting these 2 products, and to be very precise, here we will be focusing over one thing, that we are getting the salt of carboxylic acid, we are getting the salt of the acid, and this will be the alcohol. So basically if you will see this carbonyl containing group, which is the aldehyde or ketone, you will be able to focus that here we are getting this as the oxidized product. This is going to be the oxidized product, and this is going to be the reduced product. If I ask you to please focus over the functional group, so this is the aldehydic functional group. So here the aldehydic group is getting oxidized, you are getting the oxidized product, which is the acid, and here you are getting the alcohol, which is the reduced product. Just like if I give you an example that here I am having a copper plus 1. So copper plus 1 can give you copper plus 2 plus copper. So what does this mean? Here the copper plus 1 is getting oxidized to copper plus 2. So this is the oxidized product. And here the copper plus 1 is getting reduced to copper 0. So what is this? This is the reduced product. Plus 1 to 0 is reduction now. So this is the reduced product. So if you will be focusing this, so what does this mean? This simply means that here I am disproportionating this copper. So this copper is undergoing disproportionation reaction. Okay, so similarly the Cannizaro's reactions forms the disproportionated product. So here this is also disproportionation. Are you getting my point? That is, from any of the aldehyde we will be getting the 2 products. One will be the oxidized product and another is going to be the reduced product. Here the main thing about this carbonyl group is it has no alpha hydrogen, that is no acidic hydrogen. No alpha hydrogen means what? No acidic hydrogen. I hope everything is clear to all of you. Shangnik, right? Is it clear? Anu? All of you, please do let me know as and when we are moving ahead. Okay, because this is the time we have to finally understand all those reactions. Okay, otherwise there is no way. So please be focused, be active. I hope the link is working. Why I am finding that there isn't some issue? कोई तो दिक्कत चल रही है. Everything is working? Okay. The slides are visible? Okay, if there would be any issue, please do let me know. Yes? Okay, fine. Chaliye. So now here I will be taking an example to tell you, to make you understand that what has actually happened in the case of the Cannizaro's reaction, okay, and what would be the mechanism, how this mechanism occurs that we will be getting the two products, okay, chaliye. So let's move to the another slide. Mechanism of Cannizaro's reaction. Keep writing along with me. I will also be giving you the short notes of this complete name reaction part, okay, so that how you would be able to revise or recall all the things all together. So basically guys, if I take a very simple example, that is of formaldehyde, okay, I am taking a very simple example of formaldehyde. Okay, the same thing, the same question that we have, that I have given you here, the formaldehyde gives you this and this. So we want to see how does this happen. So when you have a formaldehyde, the first mole of formaldehyde, you are doing the reaction in the presence of a base. So this is going to be a step number 1. When this base is there, do you have any acidic hydrogen? No. No alpha hydrogen means there is no acidic hydrogen. Means if there is no acidic hydrogen, will it be acting as a base? No acidic hydrogen. No, it will not act as a base. If there is no acidic hydrogen, not acting as a base. Not acting as a base. Please write it everything so that it becomes easy for you to understand. Not acting as a base. Therefore, it will act as a, now it will act as a nucleophile because there is no proton to abstract. So ultimately it will not be acting as a base, it will be acting as a nucleophile. So if it is acting as a nucleophile, where it would attack? Now being acting as a nucleophile, this will attack over this carbonyl center. This is the electron deficient center and try to do the nucleophilic addition reaction. Ultimately we will be getting the OH, this will become O negative and this is the hydrogen, this is what we are getting. So this is the product so formed. When you will see this particular product, you will find that here we have O negative. Is this O negative is a better nucleophile? Because in the step number 2, we have to again do the reaction. But this is a poor nucleophile. Why this is a poor nucleophile? Because negative charge is stabilized over the oxygen atom. Is stabilized over the oxygen atom. So oxygen is an electronegative atom, so negative charge over the oxygen atom is more stable, so it becomes a poor nucleophile. So reason being, what this will undergo? This will give the electron to this carbon and here the hydride will be a nucleophile. Ultimately what is happening, please focus here, this is a very important step because this is very stable and a poor nucleophile, we will say that it will result into the formation of this kind of carbonyl group. This will remain your OH part and here we will be getting H negative and this is going to be a better nucleophile. Now this is going to be a better nucleophile. So if this is going to be a better nucleophile, now in the step number 2, now here we comes with the step number 2. In the step number 2, there will be the attack of a nucleophile or hydride over the another aldehydic group, over the another formaldehyde. Okay, so now this is the second part that we have to do. Now if we are having the another aldehyde, another formaldehyde, and we are having H negative as a nucleophile, so now what this nucleophile will do? This nucleophile will again attack over the carbonyl carbon. This bond will be broken in such a way, and we will be getting HCH. This will become O negative. This is already H. Okay, so now this is so formed, and so this is one of the product, this is one of the product, okay, and this is the another product. So if a question asks you, okay, these are the two products, so the in final, if you will follow the reaction, so the final products that we are getting is finally this is the product 1, this is the product, and this is also the product. So when you will be focusing over the two products that are formed by the two reactions, by the two steps, the step number 1 and the step number 2. So finally what you will focus over, that I got HCH, H, and this is O negative, and I am getting HC double bond O and H, right? This is the formic acid. So now out of all this, what we will figure it out, that this is a very acidic species, and here the negative charge is resonance stabilized, and so therefore this is the alcohol which will abstract this particular hydrogen, and resultantly we will be getting HCCC, and this is going to be the OH, and this will become HCOO negative. So definitely when you have taken a base, if you are having OH negative, you will definitely be having the Na positive. So this Na positive will form a salt with this. So ultimately these are the two products that we are getting. One is the alcohol and the another is the acid. That is the salt of acid. I can say that salt of acid. So the salt of acid is basically the oxidized product. So salt of acid is the oxidized product, and this, the alcohol, is basically the reduced product. Okay, so we are getting two products. One is the oxidized product and the another is the reduced product. You all understood what is Cannizaro? So the very first step is, why in the Cannizaro? Again, you come up, let us have a quick recap. In the case of the Cannizaro, this was a base, but it was unluckily it was not acting as a base. It was a base, but it is not acting as a base. Why it is not acting as a base? The reason being, we don't have any acidic hydrogen. So ultimately it has to act as a nucleophile and try to attack as a nucleophile. And since it was attacking as a nucleophile, we got this as the species. And here we found that this is a very poor nucleophile. And reason being a poor nucleophile, we will be getting H negative as a better nucleophile there. So the main reaction, the main step that involves in this particular Cannizaro's reaction is attack of a nucleophile or hydride. That is, the hydride is going to attack, not the oxygen. So hydride will attack over the another carbonyl group, and this is known as cross Cannizaro's reaction. That is self Cannizaro. Within a molecule, two formaldehyde molecules reacting together to give you this as a product. Is this clear to everyone? Is this clear to everyone? Yeah, Utkarsh, we can say that this is a kind of a nucleophilic addition mechanism. Okay, but the nucleophilic addition is happening, but not the electrophile is attacking. So in short, we cannot say that this is nucleophilic addition, but it's a kind of a nucleophilic addition. Okay, got it? Chale guys. Now let us do the same Cannizaro's reaction over one of the other molecule. है ना? So here I have taken formaldehyde. What if I will be having any kind of benzaldehyde or something else? Then how we can do the question? Okay. Now let's talk about the cross Cannizaro. If I will be having two carbonyl groups, let me tell you. Let us do the another reaction, that is the cross Cannizaro. Cross Cannizaro, you will better understand here. Cross Cannizaro's reaction. Okay, so what does this mean? This simply means that if I will be taking two molecules, one is going to be the formaldehyde and the another is going to be the benzaldehyde. And the main identification feature of this Cannizaro is you don't have any acidic hydrogen. You don't have any acidic hydrogen. So basically when you will focus over this particular reaction, This is another example number 2. We have this particular molecule. Do you have any alpha hydrogen? No alpha hydrogen. Here if you will see, do you have any alpha hydrogen? No alpha hydrogen. So both of them are not having any alpha hydrogens. Okay, so these are the carbonyl compounds, either aldehyde or ketone, but they are not having any alpha hydrogen. Okay, means no acidic hydrogens, no acidic hydrogens, no acidic hydrogens, no acidic hydrogens. Okay, ultimately in this presence, when you have a base, any base you can take, in the presence of any base, what will happen? You will be getting two products. Okay, one of them is going to be the oxidized product, that is the sodium salt of carboxylic acid, and the second one is going to be the alcohol, that is CH2OH. Okay, so this, if you will see, is the oxidized product, and this is going to be the reduced product. Now you would be asking me, ma'am, how would you recognize that this is the oxidized product, this is the reduced product? Because here we are having two types of aldehydes or ketones. Then how to identify that which will be getting oxidized, which will be getting reduced? So let me tell you, the one which is more reactive, you know, if we do the nucleophilic addition or nucleophilic substitution reactions, always aldehydes are more reactive than ketones, and the formaldehyde is more reactive than the benzaldehyde. So any of the species, let's say if it is more reactive, this is more reactive. I will tell you while the mechanism how it is more reactive, and this is less reactive. Less reactive. So one more thing you need to understand, that the species which is more reactive, the species which is more reactive will form the oxidized product, and the species which is less reactive and the species which is less reactive will form the reduced product. Are you getting it? Means the species which is more reactive will give you the oxidized product, and the species which is less reactive will give you the reduced product. Now let us look for the mechanism, how it is actually happening. Okay, let's focus over the mechanism. Ready bachcho? Ready to know that how we are getting all this? Very nice. Okay, so if we are looking for the mechanism, now see, the first step is I have these two things and I have to do the reaction with the base. For the base, do we have any acidic hydrogen? If you will focus over the formaldehyde, if you will focus over the benzaldehyde, over what we our base will attack. Sorry. This is benzaldehyde. Let's say any base, OH negative or NaOET, any base I can take. If you want to change the base, let me take NaOET. NaOET. So if you will see, this is OET negative. So ultimately this is a base. So if this is your base, or if this is acting as a base, then what will form? What will be the product there? Okay, or simple OH negative you can take here, or any other base you can take here. So what will be the product basically? Any base you can take. Let us take a very simple base, which is NaOH, because here my aim is to make you understand the mechanism, okay, which is an ionic compound. So when we have a base here, now the base, the question is, do we have any acidic proton? No. So will it be acting as a base? No, this will not be acting as a base. Will this be acting as a nucleophile? Yes, absolutely. This will be acting as a nucleophile. Why? Because it is not getting any acidic hydrogen. Here we don't have any alpha hydrogen. Here we don't have any alpha hydrogen. There is no alpha carbon even. So I am not having any acidic hydrogen. So this has to act as a nucleophile. So now the question is, which position is more nucleophilic? Which carbonyl center is more nucleophilic? Here we have a resonance. So because of the resonance, this is less electrophilic, but here the carbonyl center is more electrophilic. So here in this molecule, the carbonyl carbon is more electrophilic in nature. is more electrophilic in nature. So just because of the reason here the carbonyl carbon is more electrophilic or more deficient in nature. More deficient in nature because we want the deficient species. So therefore this base will first react over this carbonyl carbon. So if this base is first reacting over this carbonyl carbon, we will be getting HCl. So we can say that this is more reactive. Ultimately we can say that this part is more reactive species. This is your more reactive species. So if this is more reactive, this will become O negative, H, and here you will be doing the attack of OH. Now, is this a better nucleophile? Is this O negative is a better nucleophile? No. This is a poor nucleophile, not a good nucleophile. If this is not a good nucleophile, then what will happen? It will undergo rearrangement. It will undergo rearrangement. The bond will be broken like this and you will be getting hydride. That is, we will be getting HC double bond O, OH plus hydride. Now in the second step, what will happen? Now in the step number 2, the hydride attack will happen. Now let's have a focus over this. This was the step number 1. Now the step number 2. In the step number 2, the hydride attack. We have to carry out the hydride attack. That is the nucleophilic attack. Nucleophile attack over the another molecule. Nucleophile attack on another molecule. Another species or another molecule. Now when the hydride or nucleophile attack on another species, which is the benzaldehyde. So let's say this is our benzaldehyde. And over this, when this hydride will attack, so where this hydride will attack? Over this carbonyl center, very obvious because no acidic hydrogen, this cannot act as a base. Ultimately, this will be undergoing the bond breaking like this. H will be there and we will be getting O negative. This is the species so formed. Of course, this bond has to be broken. The O negative we will be getting. Now, what is the final conclusion? So, this is a kind of the phenoxide ion. This is a kind of this phenoxide ion. And here we got this as a product. So, there are two products. One is this and the another product is this. But if you will figure it out of these two products, what you will be finding it, ki out of these two products, you will figure it out ki here this is a very stable resonance stabilized species. So this will give you HCO O negative, and this species will be carrying its acidic hydrogen. This species will be carrying its acidic hydrogen, and so therefore this will become the alcohol. That is CH, H and OH. So this has abstracted the acidic hydrogen and this has become the alcohol. That is the reduced product. This is the reduced product. And this part will become HCOO negative. The one which was more reactive has become HCOO negative and Na positive. That is the salt of carboxylic acid. Salt of carboxylic acid. Ultimately, what we can say that? We can say that this is the oxidized product. Oxidized product. Is this clear to everyone? And this is the reduced product. Understood what is Cannizaro? How to do the Cannizaro? Yes, all of you understood. So this is the way how the cross Cannizaro reactions occur. So what is the most important step is this hydride attack, because the oxygen being very electronegative species and the negative charge is more stable, it's not a good nucleophile. So hydride is a better nucleophile then. So we can say that hydride is better than O negative. That's why hydride attack is happening, not the O negative attack. Clear? Chaliye. Now let's move ahead with the another name reaction, that will be the aldol condensation. Okay, that will be the aldol condensation. So when we have to focus over, ma'am, there was a leg. Pragya is saying that there is a leg. Okay, chaliye. Now we will be focusing over the aldol condensation reaction. So what reaction is this? How we can figure it out? Now guys, here I am going to take another molecule for you. Let's say I have taken a molecule like CH3 C double bond O CH3. Okay, I have taken 2 moles of this. Let's say I have taken 2 moles of this. So first of all, I will be telling you about the self-aldol condensation. Self-aldol condensation. Self means there will be a condensation, there will be 2 molecules that will be combining together. There will be condensation with the loss of water. But here we will be having 2 molecules. They are doing self-condensation. Okay, reacting with itself. So when we have such a molecule and we do the reaction in the presence of a base, of course, here also we will carry out a base, the presence of a base. We will be getting the product like, हमें product मिलेगा CH3 COH and CH2 C double bond O CH3, something like this. Okay, okay, we will be getting something like this. So when you will see this particular product, what is this? How to know that this is aldol? So when this reaction occurs, we are getting this as a product. And this is a simple species in the presence of a base. This is species, but the most important thing that we have to focus is this is the alpha carbon. This is also the alpha carbon. Do you have alpha carbons? Yes. We have the alpha hydrogens as well. There is a presence of alpha hydrogen. If this is the alpha hydrogen, are these the acidic hydrogens? Yes. We have 6 acidic hydrogen. We have 6 acidic hydrogen atoms. So all the alpha hydrogens are basically acidic in nature. We have 6 acidic hydrogens. Okay, so this is the identification of the aldol condensation. And if you will see the product here, you can say that this is the carbonyl group, this is alpha, this is beta. So you can say that this is beta hydroxyl carbonyl compound. Beta hydroxyl carbonyl compound. So this is what we can say, beta hydroxyl carbonyl compound. If you will see that here we are having the aldehydic or ketonic group and the hydroxyl group. So this is also known as aldol. Aldol. Why aldol? Aldol means aldehyde, either aldehyde or ketones, or OH is for the alcohol. So ultimately if we are getting these 2 functional groups, one is the aldehyde or ketone and another is the alcohol, we can say that this is the aldol. This is known as aldol. So aldol is basically beta hydroxyl carbonyl compound is aldol. And because of one of the reason, what is the reason behind it? Let me take green color. That we have more acidic hydrogens, है ना? Here over the alpha position we are having more acidic hydrogens, more alpha hydrogens are there. So if we do the elimination of water, if we do the dehydration or some way, if we do the elimination of water, then this hydrogen and this oxygen will get eliminated, and ultimately we will be getting CH3C. This is going to be CH3 double bond CH single bond C double bond O CH3. And if you will see this particular molecule, this is the functional group. So this is your alpha position, this is your beta position. Now this is known as alpha beta unsaturated carbonyl compounds. Alpha beta unsaturated carbonyl compounds. So ultimately you will be getting such a product. So here when we do the aldol condensation, we will be getting a product like beta hydroxyl carbonyl compound, and when we do the elimination of water, we will be getting the alpha beta unsaturated carbonyl compounds. But now the question is how the mechanism will occur, how we will be getting this as a product. Okay, so this is a question which is coming in our mind. So let's have a look for this, how we can do the self condensation. Okay, what is the product, how to do the mechanism? So mechanism of aldol condensation, the mechanisms, the reaction becomes very easy. Okay, as in when we focus over the mechanism, the reaction becomes very easy. Okay, I have taken acetone now. Yeah. CH3 C double bond O CH3. When in the presence of a base the reaction attacks, what will happen? Now this is a base. Can this a base or a nucleophile? Yes, this is a base. On priority we will consider this as a base. Okay, if it is a base, if we have the acidic hydrogen, yes, we do have the acidic hydrogens. Do we have the acidic hydrogens? Yes, we have the acidic hydrogens. Then definitely it will be acting as a base. So being acting as a base, this will try to abstract the acidic hydrogen and ultimately results into the formation of C double bond O CH2 negative. Okay, and there will be a loss of water. The water will get eliminated, you will be getting CH2 negative. And when you will see, this will undergo resonance, this negative charge will undergo resonance like this, and we will be getting CH3CO negative and double bond is CH2. Now you tell me, out of these two, which is a better nucleophile? Now here we can say that this is a better nucleophile. This is a better nucleophile, but not this. Not a good nucleophile. Not a good nucleophile. Why? Because here the negative charge is stabilized over the oxygen atom. Negative charge stabilized over the electronegative atom. So as the nature of the atom, as the nature of the charge. So negative charge stabilized over the electronegative atom, and so therefore it's not a good nucleophile. Ultimately this is my better nucleophile, so my choice is this. This is my choice. If this is my choice, now in the step number 2 what will happen? This is the step number 1. In the step number 2, we will be taking the another species, that is the another ketone, and we will ask this nucleophile to attack. That is CH3 C double bond O CH2. This was a nucleophile. Now this nucleophile will attack. Now what this will do? This nucleophile will attack as a this will do the nucleophilic addition, or this will again abstract the acidic hydrogen. Now let me tell you guys, this is not a base. This is not a base. This is only a nucleophile. Okay. Here we are having carbon by negative. It's not an ionic bond or will be acting as a base or abstract the hydrogen. It is acting as a nucleophile. So now we will be getting the nucleophilic addition mechanism, nucleophilic addition reaction. Okay. So how this will happen? This nucleophile will attack over this carbonyl center. Ultimately we will be getting, guys just give me a minute. I'm just coming. Just a second. So hello everyone, sorry for the interruption. let's continue with the mechanism. So if we do this kind of nucleophilic addition mechanism, now tell me what will happen. Think about it. This nucleophile will attack over this carbonyl carbon and the bond has to be broken. Okay, of course we will be getting O negative, and here we will be getting, let's put CH3 here, है ना? And this nucleophile will attack over this carbonyl center. So I can say that CH2, C double bond O, and CH3. Okay, so ultimately I can show it like this. Thus this nucleophile, है ना? This nucleophile is attacking over this carbonyl center. Okay, and this part is basically your this part. This bond has been broken. This is CH3, CCH3, CH3, CCH3. This is O negative, and here this nucleophile is being attacking. Clear? And so therefore we can say that this is the nucleophilic addition mechanism. This is the first part, this is the second part. This is the second part. Clear? Got it? So ultimately there is a bond formation between this carbon and this carbon. Okay. Now what happens next? In the next step, what we have to do? Here we are having O negative, and we already know that the reaction, there is a presence of a water. So in the presence of this water, this O negative will pull the H positive from the water. Ultimately we will be getting CH3COH. This will be CH3, this is CH2, C double bond O, and CH3. Okay, so what is this? This is your aldol. This is your beta hydroxyl carbonyl compound. Beta hydroxyl carbonyl compound. Now, if you figure it out in the another way, that is, if I do the elimination of water, I would say that okay, I am having one more acidic hydrogen. So if you have this acidic hydrogen and if you have this OH, which can be protonated and become a good leaving group. Okay, so ultimately again what can happen, because in the presence of a base, this the base in the presence of a base, the reaction is happening. No, it will abstract the proton, and so ultimately we will be getting CH3 C double bond CH C double bond O CH3 by the elimination of water. And this we can say that this is the even CB mechanism. Even CB mechanism, that is the elimination of water in the presence of a base. The reaction is catalyzed in the presence of a base. So in the presence of a base, the even CB mechanism will occur and there will be the elimination of water. Now this is alpha beta unsaturated carbonyl compound. Got it? So this is as simple as that. Okay, so this is your mechanism of the aldol condensations. Okay, so you understood what is the difference. In the case of Cannizaro, we were not having the acidic hydrogen, so it was acting as a nucleophile. But in the case of the aldol, we do have the alpha hydrogen, so it is acting as a base, not as a nucleophile. And these are the products so formed, this and this. Okay, now I will be giving you a mechanism of the cross aldol condensation. What will happen if we will be having the cross aldol condensation? In the case of cross aldol condensation, we just have to see the rate of reactivity. Okay. Now, I am giving you a molecule like this plus this in the presence of a base. Your first question from me would be like, ma'am, and you have to tell the product. What would be the product in this particular question? And the answer can only be given by doing the mechanism, not by any other way. Now you would be asking me, what will be the product? There, if I see the carbonyl compound, this is a carbonyl compound with no alpha hydrogen, with no alpha hydrogen, and here this is a carbonyl group with alpha hydrogen. So ma'am, either to do the Cannizaro or either to do the Aldol, है ना? This would be a question in your mind. Whether no alpha hydrogen, with alpha hydrogen, whether I do the Cannizaro or I do the Aldol. My simple question is, your OH, which is acting as a base, is more reactive for the alpha hydrogen now. This base, it has a tendency to abstract the proton. So ultimately, out of these two reactions, which is going to be more reactive? Which is going to be more reactive? Here, this is going to be more reactive. More reactive towards base because of acidic hydrogen. Because of acidic hydrogen. Okay, so this will more reactive towards base. If I am having a base in the reaction and I am having H positive, and H positive is more reactive than the electrophilic carbon. Okay, so here I am having the electrophilic carbon, here I am having the electrophilic carbon, but here I am having the electrophilic carbon, but here I am having the H positive. So you tell me, out of these two, the electrophilic carbon, the carbonyl carbon having a positive charge, or the H positive, which is more reactive? This is more reactive than this. Okay, so H positive is more reactive than the C positive. Then the carbonyl carbon, rather than the carbonyl carbon, H positive is more reactive. So the reaction will start from here. And if the reaction is starting from the acidic hydrogen, we can say that it will follow the aldol. So this is going to be aldol, not the Cannizaro. Now let us start the mechanism. We got it that this particular species, acetone, is more reactive. So we have to see which is more reactive for the base. From that side only the mechanism will start. Okay Harsh, it's fine to me. If here I am having a base and this species is more reactive, okay, please always start your reaction from the more reactive part. Okay, if you are having two things, the base will choose the one which is more reactive. This will abstract the acidic hydrogen, will form this, and with the loss of H2O. If you will be drawing its resonating structure, okay, so I believe this carbon is already a beta nucleophile. This is already a beta nucleophile, so no point of forming another structure. So if I will be forming the resonating structure, but this is a poor nucleophile. So I will be choosing my beta nucleophile. Okay, so ultimately in the step number 2, this is the step number 1. In the step number 2, what will happen? Now you are having benzaldehyde. Now when this benzaldehyde will react with CH3 double bond O, CH2 negative, then we will be getting the nucleophilic addition reaction. Ultimately, the nucleophile will attack over this carbonyl center and the pi bond will be broken in such a way. CO negative, this is the hydrogen, this is CH2, C double bond O, CH3. So if you will see, this is this part, and this carbonyl is here. This is your carbonyl center. Clear? Ultimately, this particular species is attacking over this carbonyl center. Now, what we figured it out, if we are having this as a product and the reaction is in the presence of a water, ultimately what I will be getting is this will abstract the acidic hydrogen from it. Okay, now this is what? Aldol. Why is this aldol? Because this is alpha beta. Beta hydroxyl carbonyl compounds are aldol. Now from this aldol, because there is one more acidic hydrogen, we can do the elimination of water because we have one more acidic hydrogen. If we do the elimination of water by following the even CP mechanism, again we will be getting HC double bond CH single bond C double bond O CH3, and here I will be getting the benzene. Got it? So this is your final answer. This is your final answer. That is the alpha beta unsaturated carbonyl compound. So if someone asks you what is the answer for this particular molecule, your answer has to be कि यहाँ पे ये होगा हमारा, this is going to be, यहाँ पे होगा, we will be having the nucleophilic attack. Ultimately we will be getting HC double bond CH single bond C double bond O and CH3. So this is your major product. This is your major product. So basically I am teaching you how to form the more stable product. So of course if you are having a base and if you are having two reactants, so base will choose with which I have to react. It will look for the rate of reactivity. Okay, I am more reactive for this or I am more reactive for this. Okay, so the reaction will start from the more reactive part. Ultimately this is your final answer for the cross aldol condensation. Now you do have more reactions like the intramolecular condensation. Let me tell you about the intramolecular. Just a minute. I need to add one slide to this. Okay. I will also be telling you about the intramolecular aldol condensation, which is very, very important from the examination point of view. Intramolecular aldol condensation. So when I look for this particular molecule, I will find that, let us take an example, CH3 C double bond O, CH2 CH2 CH2, let's say this is C double bond O CH3. Okay, so whenever you have the intramolecular aldol condensation, I am talking about aldol condensation. So aldol, definitely you will be having the alpha hydrogens. Yes, they all are alpha hydrogens. This is having alpha hydrogen, alpha hydrogen, alpha hydrogen, alpha hydrogen. Alpha hydrogens are needed, and in the presence of a base, the reaction has to happen. So alpha hydrogen, we have so many alpha hydrogens. Now the reaction is based on the stability of the ring, from where the alpha hydrogen has to be extracted and from where the nucleophile has to attack. There are the two major steps in the reaction, two major steps of the mechanism. The first major step is that from where you have the acidic hydrogen, है ना, you abstraction of acidic hydrogen, and the second step is the attack of a nucleophile, on carbonyl carbon. So when we do the abstraction of acidic hydrogen, it is simply a acid-base reaction. Base is reacting with the acid. So this is simply a acid-base reaction. And when we are doing the attack of a nucleophile on the carbonyl carbon, this is a kind of a nucleophilic addition mechanism. We can say that. Okay, so these are the two steps, but when we will be focusing over the intramolecular reaction, there will be a formation of a ring. Okay, there will be a formation of a ring. And whenever there will be a formation of a ring, we have to focus over the stability of rings. And you need to know, if you are getting a 3-membered ring, this is going to be more stable than the 4-membered ring. If you are getting a 5-membered ring, then the 5-membered ring is more stable than the 4. If you are getting a 6-membered ring, 6-membered ring is more stable than the 5. If you are getting a 7-membered ring, then let me tell you 6-membered ring is more stable than the 7. So this is the stability of the ring. And stability of the ring is more preferred. And one more note, you need to write it down. One more note. Stability of the ring, stability of ring is more preferred over the acidic hydrogen. मतलब rather than looking for the most acidic hydrogen, the stability of the ring is more preferred. Stability of ring is more preferred over the acidic hydrogen. This is as per the Brett's rule. ठीक है, this is Brett's rule कि whenever there is a formation of a ring, then the stability of ring is more preferred. ठीक है, so when you will be focusing over this all such points, then you will figure it out कि when we have this as a molecule, let us do the mechanism, because without mechanism we will not be able to do anything. You are having CH3, C double bond O, CH2, 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 C double bond O, CH3. Now see, I am having this acidic hydrogen, this acidic hydrogen is also A types, they both are identical. If I will be looking for this and this, they are the B types acidic hydrogen. So when I abstract this B types acidic hydrogen, so my take is, if I will be abstracting the B acidic hydrogen, B wala, HB, if I will be abstracting with the base, I will be getting 1, 2, 3, 4. I will be getting a 4-membered ring formation. If I will be abstracting the acidic hydrogen A, I will be getting 1, 2, 3, 4, 5, 6-membered ring. I will be getting, if I will be abstracting A wala hydrogen, I will be getting a 6-membered ring. How I am saying all this? Let me prove this to you. Okay? Now let's say this is my B hydrogen, this is my A hydrogen. Okay? So I will be choosing 2 colors of pen. One is going to be blue, let's say. So here you were already having the OH negative. You were already having the OH negative. So when you were having the OH negative, and this OH negative is more interested in pulling the B hydrogen, it will result into the formation of HBOH, that is H2O, but this is the B wala hydrogen, है ना? That is the elimination of water will form. Okay, if the water will form, then you will be getting this as a nucleophile. Let me do the whole mechanism and then I show you. You will be getting this as a nucleophile, that is a CH3, C double bond O, CH2, this is CH2, this is CH negative, and then this is C double bond O, CH3, and then it's very obvious, then this nucleophile will attack, just a minute. This nucleophile will do an attack over this carbonyl center to break a bond like this. So when this bond will be forming, so 1, 2, 3, 4, we will definitely be getting a 4-membered ring. 4-membered ring. Let's say this is the carbon number, this is the carbon number 1, this is the carbon number 2, carbon number 3, carbon number 4. Okay, let's say this is 1, 2, 3, 4. So if I have to write down the complete bonds, then over the 1, I am having the carbonyl center like this, COCH3. One is attacking over, this is 2, 3, 4, and one is attacking over the 4, where I will be getting O negative, and this is going to be the methyl. And then this O negative will form OH. Okay, so this is going to be this kind of alcohol. So this aldol is basically the 4-membered ring, and I told you the 4-membered ring is less stable. Now let's figure it out when I will be eliminating. Let us do with the green color only. If I will be eliminating minus HA with the OH negative, that is if this will be eliminating, in the presence of a base, if this will get eliminated, then what we will be having the product so formed. Okay, that is if we eliminate this as the water molecule, that is A. So A could be any A. Let's say this A I have taken. So when this A I have taken, I will be getting this A, I will be getting CH3, C double bond O, CH2, 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 C double bond O, CH2 negative. This is your conjugate base, and if this is your conjugate base, this will be acting as a nucleophile, and this will try to attack over this carbonyl center, and the bond will be broken like this in such a way. If you will count the number of carbons, you will find that this is 1, 2, 3, 4, 5 and 6. These are the 6 carbons. So just form a ring of 6 carbons. Ultimately the one is forming a bond with the 6. So we will be getting a 6 membered ring. Let's say this is your 1, 2, 3, 4, 5 or 6. This is your 6 carbons. So over the carbon number 1, what are you having? Over the carbon number 1, there is nothing. We are having over the carbon number, okay, let me change the color of the pen, because otherwise it will become very confusing to all of you if I will keep using green color. Just a minute. I'm trying my best to make you understand. Rest is on you. You have to do along with me. Then only you will better understand now. This is, let's say 1, this is 2, this is 3, this is 4, this is 5, this is 6. Anyway, you can draw the number. It's all your choice. So over the 1, we have this. Over the 2, we have a double bond O. Over the 3, we have nothing. 4 CH2, 5 CH2, 6. Over the 6 carbon, we are having a breaking of this bond O negative. And over the 6, we have one methyl group as well. This is it. This is so formed. Now this O negative, what this will do? This is the nucleophilic attack. We have abstract the acidic hydrogen. The first step we did, the abstraction of acidic hydrogen. Then after abstracting the acidic hydrogen, we have to do the attack of a nucleophile on the carbonyl carbon. So this is the step number 2. Step number 1, and this is the step number 2. This is the step number 2, the attack of a nucleophile over the carbonyl carbon. That is the nucleophilic addition mechanism, isn't it? And we are getting a ring which is a 6-membered ring, and this is a stable ring formation. Ultimately it's a stable ring. Okay, so now what we can do further? We can simply say that here in the presence of the water, this O negative will pull the hydrogen, and so therefore we will be getting double bond O. This is going to be OH and the methyl, and what is this? This is alpha, this is beta, and this is your aldol. And after this we can also do the elimination of water following the even CV mechanism. And because of the even CV mechanism, the final product is going to be this, and of course we will be having a methyl there. This is it. So ultimately the product that we are getting is double bond O, double bond and methyl. That is alpha beta unsaturated carbonyl compound, and this is the product of aldol. Okay, isn't it? So this is as simple as that. This is your intramolecular aldol condensation. So I told you why the ring formation occurs. Okay, because here we have the 2 carbonyl groups in the same molecule. So definitely within a molecule the reaction has to happen. Okay, now we will be moving ahead, and this is going to be the third reaction that we will be focusing now. That is the Claisen condensation. So what do you mean by that Claisen condensation? Okay. See, let me tell you. So Claisen condensation is for the compounds having a carbonyl group. Definitely here we will be having a compounds with carbonyl group. Okay, with the alpha hydrogen, we will be having the alpha hydrogen. We will be having the carbonyl group, but along with this we will also be having the presence of esters. Okay, means do we have a carbonyl group? Yes, we have a carbonyl group. Do we have the alpha hydrogens? Yes, we have the alpha hydrogens. But here the compound is in the Claisen condensation we don't have pure carbonyl compounds. Here we will be having the derivatives of acids. That is, here we will be taking the ester as a functional group. Esters, the presence of esters is necessary. So here what we will be having? We will be having a presence of esters. Carbonyl group, yeah, of course we have this as a carbonyl center. We have the alpha hydrogen, but we have the esters. And there must be a 2 alpha hydrogens. There is one more conformation, there must be 2 alpha hydrogens. Must be 2 alpha hydrogens. Must be a presence of 2 alpha hydrogens. These are the necessary conditions for this Claisen condensation reaction. So when you have this as a molecule, and if you treat it in the presence of a base, again any kind of base you can take, let's say you have taken ETONA, so ultimately it is also a base, and in the presence of a base, here this will result into the formation of sodium salt of beta ketoester. What will form? Sodium salt of beta ketoester. Okay, let's say you will be getting ester this. So what is this? If you will figure it out, this as a molecule, this is ester, this is alpha position, this is beta position. So we can say that this is beta keto. Over the beta we have a ketonic as a functional group, beta keto ester. And is this only beta keto ester? No, this is a salt of beta keto ester. If this is a sodium, so we can say that this is the sodium salt of beta keto ester. So this is the product of Claisen condensation. That is the sodium salt of beta keto ester. But the question is how it is forming and why this sodium salt of beta keto ester is a stable product. Now if you will want to draw its diagram, अगर आपको इसको इसे visualize करना है, so you better visualize it like you have a C double bond O. This is going to be CH2 CH. I could say CH only, not CH2. CH only. Okay, and this is going to be C double bond O. This is O, CH2, CH3. This is again the methyl, and here the negative part, and here we will be having Na positive. It's an ionic bond. So basically what they are forming, this pi bond will get delocalized, this negative charge will get delocalized like this bond will get will be broken in such a way, this Na positive will react here, this will react like this pi bond will go delocalization like this. So ultimately this is a formation of this kind of a 6-membered ring, and ultimately we can say that the negative charge is getting delocalized. So if I draw the another structure of this molecule, I can say that this is O, this is CH, this is C, O, Na, and here this is Na positive, and this is O, CH2, CH3. I can show it like this, something that from here to here the negative charge is getting delocalized. Yeah, over the oxygen, this carbon, because this negative and this pi bond are in delocalization, so it will delocalize to give you over the O. So this negative charge is getting delocalized over the carbon and oxygen, and here also this negative charge will undergo delocalization with this oxygen. This negative and this double bond are forming a resonating system, so it is delocalizing over this to this. So ultimately the negative charge is delocalizing from here to here, and ultimately here we have a Na positive, so it will form an ionic bond. एक तरीके से ion dipole interaction we will be having, ion dipole interaction, and because of this ion dipole interaction it will result into the formation of a ring which will known as chelation, and this chelation gives you a stable product. Got it? So this negative charge is moving from this to this, so that's why we are saying that this is a chelation, and ultimately this will be a stable product. So you need to remember what will be the product. So what are the necessary conditions? Here we will be having a carbonyl group, but it is going to be it is not the pure carbonyl group. It is not a pure carbonyl group. Pure carbonyl groups we usually take in the case of the aldol. Here we have a carbonyl group, but along with the ester. Okay, and it must be having 2 alpha hydrogens. Why there is a necessary condition of the 2 alpha hydrogens? ठीक है, Let's focus on it. Let's focus on it. चलिए. So let me make you do the mechanism of it. Okay. We will be able to do here only. So if I'm having CH3, CO, CH2, CH3 in the step number 1, you are having a presence of a base which is OET negative. So what this OET negative will do, this OET negative will try to pull the acidic hydrogen. So here we have the acidic hydrogen. Of course, it will be acting as a base if there is a presence of alpha hydrogen. If you have the alpha hydrogen, it will be more reactive as a base, not as a nucleophile. It will abstract the base, acidic hydrogen. You will be getting, and this is a better nucleophile. You can form its resonating structure, but that will not be a better nucleophile. Is this a better nucleophile? No, this is a better nucleophile. Okay, so we will be choosing this. Now in the step number 2, again another mole of the same species we will be taking. Another mole of same species, and here this particular species, the nucleophile that we have generated, the nucleophilic attack we will be doing. By what mechanism? That is the nucleophilic addition or substitution. You do let me know. Here it is going to be the nucleophilic addition or nucleophilic substitution. Here it is going to be the nucleophilic substitution or addition. Tell me. Nucleophilic substitution. Why? Because here we have a leaving group. This is a leaving group. So whenever we have the esters or acid halides or anhydrides, this is acting as a leaving group. So ultimately this will become, this will leave, right? So this nucleophile will attack like this. The bond will be broken, the bond will be formed, and this is the nucleophilic substitution mechanism, and this is known as SN2TH mechanism. Ultimately we will be getting CO double bond O, and here the leaving group will leave, and we will be getting CH2 C double bond O, O, CH2 CH3. So if you will see what I have done, this is a part which has attacked over this part, and this is your this part, and this is your this part. This is a leaving group which has been left. So the leaving group has been left and this has attacked over this particular part. Is this clear? Now this is beta keto ester. Okay, what is this simply? Sorry. Shit, what has happened? इसे क्या हो गया? रब हो गया सारा. Shit man. How come not done? क्या हुआ? कुछ समझ नहीं आया क्या हुआ. किसी को समझ आया क्या हुआ? ये रब कैसे हुआ? So basically let me write it here. I hope you people have written it. तो हमारा कुछ ऐसे बना था. We got CH3, C double bond O, CH2, COO, COO, CH2, CH3, है ना, कुछ ऐसे हुआ था हमारा, ठीक है. So in the next step, so ultimately we can say that this is your ester and this is the alpha, this is the beta. So this is your beta keto ester. You can say that this is beta keto ester. But beta keto ester is not stable. Okay. Here we are having two carbonyl groups, but it is not stable. So if you have one more acidic hydrogen, now here we can see that we have one more acidic hydrogen. One more acidic hydrogen. So because of the presence of one more acidic hydrogen in the presence of a base OET negative, this will abstract one more hydrogen, resulting into the formation of a CH3, C double bond O, CH negative, and C double bond O, O, CH2, CH3, and Na positive. Got it? And so therefore, because of the one more acidic hydrogen, because of the presence of one more acidic hydrogen, it will result into the formation of a sodium salt of sodium salt of beta keto ester. Write it down. Clear? How the sodium salt of beta keto ester form? मतलब I am not able to identify कि what has happened in between, है ना, एकदम अचानक से ये सारा कैसे रहा हो गया. चलो, I believe that you people got it. How to get the answer? Even मैं वही कोशिश कर रही हूँ. I'm trying to looking for the video that what I have done wrong in the previous step. I just took the pen and somehow I may just clicked over the erase all. No idea. Chaliye. Now I will be giving you an example of the actually by mistake this has happened. I have erased, I just click like this and erase all link on slide has happened rather than changing the color of the pen. That's why this all has happened. Okay. Chalo. So basically I believe that you people understood that what is the beta keto ester, right? The reaction, the mechanism you people understood. Now similarly we can do this kind of reaction for any of the molecule. Now the next reaction that I am having for you is the Perkins reaction. Okay, that is the Perkins reaction. So what is it? What reaction is this? Let's have a look. See, in the Perkins reaction, we have to take the anhydrides. We have to take the anhydrides. Example, anhydrides with 2 alpha hydrogen, anhydrides with 2 alpha hydrogen. Okay, so here let me take a reaction. If I will be having any kind of molecule, let's say this is this, okay, if this is aldehyde, it's fine, no issues with that. But one of them has to be anhydride, at least one of them. Either you have 2 anhydrides or at least you have one of them as anhydride. Anhydride is necessary. Okay, so anhydride is necessary. So let me take one of the molecule as then only it will be considered as the Perkins reaction. Okay, so the necessary condition is anhydride and with at least 2 alpha hydrogens. So these are the necessary conditions and the reaction is absolutely be occurring in the presence of a base, and in the presence of a base when you will be doing the reaction, it will result into the formation of what? Any idea? This, that is cinnamic acid. So the product of the The product of the Perkins reaction is going to be the cinnamic acid, and it is going to be the trans alkene. If you will see the stereo of this molecule, it has to be trans. Okay. Now let me show you the mechanism how this reaction occurs. We can take any base. Any base will work. Not necessarily OH has to be there. It could be NaOET or sodium salt of acetic acid. Any salt will work. Now let me take an example. If I am having a benzaldehyde and along with the anhydride, this is your anhydride now. In the presence of a base like, let me take a base like CH3COO negative Na positive, any base will work, okay. So here I am taking, let's say I am taking this as a base. So if I try to do the reaction considering this as a base, this has alpha hydrogens, but here I am having no alpha hydrogen. So ultimately who will be more reactive? This anhydride is more reactive. So from wherever the species is more reactive, my reaction will start from there only. This is less reactive, no alpha hydrogen, so no, not reactive. So base will react with the alpha hydrogen, there will be the acid base reaction. Ultimately we will be getting CH2 negative. Let's say this has pulled this alpha hydrogen, CH2 negative, C double bond O, C double bond O and CH3. And if you will form its resonating structure, this will go like this, this will go like this. You will be getting CH2 double bond CO negative, O, C double bond O, CH3. But out of these two, when you will figure it out, you will find that this is a better nucleophile rather than this. Is this a better nucleophile? No, this is not a better nucleophile. Why? Because the negative charge is more stable over the oxygen. So this is more stable and hence it is less reactive, more stable. So nucleophilicity decreases. Got it? So this is a better nucleophile. Now we have in the step number 2. In the step number 2, what will happen? In the step number 2, we have benzaldehyde. Now this part will react with water, with this species, this as a nucleophile. Now when we will be focusing over, okay, what the reaction will occur, now this will do the nucleophilic addition mechanism. This nucleophile will attack and there is no leaving group. So we will be doing the nucleophilic addition. And since the nucleophilic addition will happen, no leaving group, so we can't do the substitution, only addition can happen. This will become CO negative. Let me put hydrogen that particular side. And here the CH2, C double bond O, C double bond O, CH3 will form. Now let's have a look. This is a nucleophile which is attacking, this is a nucleophile which is attacking, and here we have this as the carbonyl center. So this is the carbonyl center where the nucleophile is getting attacked. Got it? So this nucleophile is attacking over this particular carbonyl center. Is this clear? Nucleophilic addition mechanism has happened. Now if you will see the product, what it is, you will find that this is having O negative. Again in the next step it will try to react with the water, will form alcohol. Very simple step. This carbon, this O, the electrophile will attack, you will be getting H. This is again CH2, this is CO, O, CO, CH3. So if you will see this particular product, you will find that this is the alpha, this is the beta. So this is the beta hydroxyl anhydride, है ना? So we can say that this is beta hydroxyl, just like in the case of Aldol, we were getting beta hydroxyl carbonyl compound. Here we are getting beta hydroxyl anhydride. But is this the product? No, this is not the stable product. This is not the stable product. Still some other things has to happen. So what are those other things? Guys, we have one more acidic hydrogen, more alpha hydrogen. So if we have more alpha hydrogen, what we can do? We can do the elimination of water. So elimination of water will happen in the presence of a base which is OAC negative. है ना? We have the acetate ion in the presence of a base. There will be the elimination of not water, there will be the elimination of acetic acid. Let me do it again. So here if you are taking OCOCH3 negative, if this will abstract the acidic hydrogen, there we will be getting the loss of acetic acid, and since there will be a loss of acetic acid, there will be the elimination of water as well. There we will be having the elimination of this OH, and this AH will get eliminated. Ultimately we will be getting the double bond CH, single bond CO OCH3. This we can say that this is alpha beta, this is alpha beta unsaturated anhydride. We can say that this is alpha beta unsaturated anhydride. Is this the final product? No, not still. There is one more possibility. What is that possibility? That we do have the we do have the water. So in the presence of water, in the presence of a base, we can do the basic hydrolysis. If you will see, we can do the basic hydrolysis. In the presence of OAC negative and the water, we can do the basic hydrolysis. And if the basic hydrolysis has to occur, this part will be broken, OH will go there, H will go there. Ultimately, we will be getting the synamic system. CH, if you want to form it stereo, you can figure it out in such a way that it will be stereo specific. CH double bond C, this is going to be H, this is going to be C double bond O, OH, carboxylic acid, and this will be the methanol. Got it? So this will be the product. Now why I formed transalkene? What is the need of forming the transalkene? The reason is transalkene because of the less steric repulsion. This is more stable, है ना? क्योंकि trans में क्या होता है? When we have the two groups which are in the opposite direction, there will be less repulsion. Less repulsion means there will be more stability. So ultimately, this is your product, which is the extra stable product, which is the synamic system. Got it? This is how the reaction occurs. Clear everyone? So this is your Perkins reaction. Now we have one more reaction, that is that will be your Gabriel phthalamide synthesis. Okay? That would be the last reaction which I will be telling you today. I hope if you are attending this lecture thoroughly, step by step, then very easily you will be able to do all those reactions. Okay? I guarantee you. I will also come up with more sessions where I will be giving you questions. Right now in this class I am teaching you the reaction, how to do them. But in the another lecture I will be bringing up with the questions you have to do them. Clear? Chaliye. So Gabriel phthalamide synthesis of primary amine. So here also we take one of the thing which is basically okay. So what is this? This is a kind of amide group, है ना? We have CONHCO, so we can say that this is also having a carbonyl group but with the NH, है ना? So अगर if you will see, you will find that this is also a carbonyl group containing compounds, carbonyl group containing compound, carbonyl group containing compound along with the acidic hydrogen. So where you can see this acidic hydrogen, guys, this hydrogen is acidic. This NH hydrogen is acidic. Okay. So when we have this kind of species and we do the reaction with the base, okay, of course the first thing we must have is the base. The second thing that we must have the alkyl halide, and the third thing that we will be having we will be doing the base in the presence of water. That is the basic hydrolysis, or you can say. ठीक है, aqueous base, or you can say basic hydrolysis, you can write it like this, OH negative in the presence of water. ठीक है, so if you will follow these 3 steps, so you will be getting the synthesis of primary amine. Now let me tell you how the primary amine you will be getting. So the R that you are getting here, you will be getting RNH2. This is your 1 degree amine. So this is the preparation of this kind of species. Now let me go with the mechanism for you, that how does this happen. If you will follow the mechanism, here we have this kind of species, which is this, and whenever you have a base, what you do, whenever you have a base KOH negative, K positive, OH negative, you always look for the acidic hydrogen. This is the thing that we do in every other step. Last time भी ऐसे ही हुआ था, right? So this is a base that will be looking for this acidic hydrogen, ultimately resulting into the formation of a double bond O N negative, this, okay, pulling the H2O, pulling the water. Ultimately there we will be having the loss of water. Why I am doing this much of rubbing? Just to make you understand thoroughly, and so that the slides be very very neat. Okay, now if you are getting this as a conjugate base, you will say that ma'am, this will be shit man. You will say that ma'am, this is going to be the resonance stabilized molecule. You can do the resonance. This negative go there, this bond will go there, and if you will do the resonance, you will figure it out. You are getting O negative double bond N, and this is again going to be double bond O. Now if I say that these are the two resonating structures, which is a better nucleophile? This is a better nucleophile. Why? Because negative is more stable over the oxygen atom. So here negative is over the oxygen, here negative is over the nitrogen. So nitrogen, being a less electronegative atom, is a better nucleophile. So this nitrogen, the negative charge over nitrogen, is a better nucleophile. Okay, it will be having a better reactivity. So if we have such kind of a species, now this will undergo the step number 2. This is the step number 1. Now the step number 2 is, we will do the attack. Now this nucleophile will attack over what? Where? We do have another molecule of this? No, here we have Rx now. There is a difference. Now this N negative will attack over Rx, ultimately giving you the SN2 mechanism. Following the SN2 mechanism, ultimately getting double bond O, this is NR. Okay, this is NR. So after getting NR, what you can do? Okay, the step number 1 has happened, step number 2 has happened. Now what will happen? Now the step number 3 will happen now. Step number 3, that is basic hydrolysis. So if you have to do the basic hydrolysis, and this is a kind of amide as a functional group. Okay, so if you will do the basic hydrolysis, here you will be getting NH, and this there you will be getting OH. है ना? If you do the basic hydrolysis, we will be getting H and OH. Nitrogen being having a lone pair of electron, it will react with the H part. Okay, and if this way you will do the basic hydrolysis, you will be getting double bond O, OH, and this part will give you double bond O, N. This is R and this is H. Okay, this is what has happened. Now again we can do the basic hydrolysis. We have again an amide. Again we can do the basic hydrolysis. So if we do the again basic hydrolysis, what we will be getting? Let me change the color. This bond will be broken. OH will go there, H will go there. Ultimately we will be getting the formation of a double bond OOH. This is also double bond OOH plus N pair. We have H already, one more H will be there and R will be there, and this is the lone pair. Ultimately, what are the products so formed? This is phthalamide. This is phthalamide. Now this will be known as the phthalic acid. and this will be known as the 1-degree amine. So this is how the Gabriel phthalamide synthesis of primary amines takes place. So we have started with the phthalamide, and from the phthalamide we form the 1-degree amine. So as simple as that. So one thing that you have focused in all these reactions is that they are following a certain mechanism. We all have the carbonyl center. We either have the alpha hydrogen, we don't have the alpha hydrogen, we do have the one alpha hydrogen or more than one alpha hydrogen. Okay, and so therefore when these reactions occurs in the presence of a base, we have to see the further rate of reactivity and then the products so formed. Okay, so ultimately if I have to compile all the things in one go, I would say that I have given you the Cannizaro's reaction. Okay, the 5 reactions, no, Cannizaro's reaction. We have done the Cannizaro's reaction. So in the Cannizaro's reaction, what was the most important part? Here we have to take the pure carbonyl compounds, only aldehydes and ketones, only aldehydes and ketones with no alpha hydrogen. This was the necessary condition for this, है ना, with no alpha hydrogen. So when we have this in the presence of a base, the reaction will occur, and since the reaction will occur in the presence of a base, it will be acting as a nucleophile. Base act as a nucleophile, and we get the base rather than base. This act as a nucleophile की तरह वो attack करता है, and the hydride attack will happen, and so therefore the product so formed is going to be the acids and alcohols. The product that you will be getting are going to be the acids and alcohols. Acids, the most reactive one, जो most reactive होगा, the most reactive will give you the acid, and जो less reactive होगा, that will give you the alcohol. So ultimately it is an example of disproportionated product you will be getting, acids plus alcohols, or we can say that acids, the salt of acids, the sodium salt or whatever the salt of acids plus alcohols. These are the product that you will be getting. Now the another reaction that we have done is the aldol condensation. Aldol condensation. In the aldol condensation, we want aldehydes and ketones with one or more than one alpha hydrogen. More than one alpha hydrogen. Matlab either one or with no more than one alpha hydrogen will work. Here we have a base, and it acts as a base only. And if act as a base, then it will attack on the acidic hydrogen, will generate a nucleophile and will do the nucleophilic addition mechanism. So what will be the product so formed here is, if you will form the product, you will be getting beta hydroxyl carbonyl compound. That is, we will be having CH2, we will be having CPA, beta, let's say this is your alpha, this is your beta, beta hydroxyl carbonyl group. Such kind of compounds will form. ठीक है, यानी कि this is alpha beta, means beta hydroxyl carbonyl group, carbonyl compound. And if you have one more alpha hydrogen, then what can happen? This can result into the formation of alpha beta unsaturated carbonyl compound. Okay, so this is a summary that you need to remember. That is, you will be having C double bond C, CH, okay, C double bond O, and this is R. This is alpha beta unsaturated carbonyl compound. If you have one alpha hydrogen, this will be the product. If you have two alpha hydrogens, that will be the product. Now the third reaction that we have done is basically the Cannizaro, Aldol, then we did Claisen. Claisen. For the Claisen, we must have the esters. We must have the esters with at least 2 alpha hydrogens, with at least 2 alpha hydrogens. If you will not be having 2 alpha hydrogens, it will not be forming the stable product. Here we have no alpha hydrogen, here one or more than one alpha hydrogen, and here at least 2 alpha hydrogens. This is a difference, okay. Now here also the reaction will occur in the presence of a base. If this is acting as a base, absolutely it will remain acting as a base, and the nucleophilic substitution mechanism will occur. Why nucleophilic substitution? Because here we have the leaving group. So because we have a leaving group, that's why the substitution will occur rather than the nucleophilic addition. Okay, and so therefore if we have the 1 alpha hydrogen, and so therefore we will be forming the beta keto ester, that is R C double bond O. This is going to be CH2, C double bond O, O and R dash. That is, we can say that this is beta keto ester. But if you have one more acidic hydrogen, you can form the salt of beta keto ester, which will be more stable product. RCO CH CO O R dash, that is, the negative charge will be stable, and here you will be getting Na positive. Okay, this kind of interaction, salt of beta keto ester will be the product. Now the fourth reaction which I have discussed with you is the Perkins reaction. Now in the Perkins reaction, what is required? In the Perkins reaction, you must have the anhydride. You must have the anhydride, and anhydride with how many alpha hydrogens? With at least 2 alpha hydrogens. Why? And the basic hydrolysis will also happen. Again, the reaction is in the presence of a base. Here also it will be acting as a base. Only in this reaction that it will not act as a base, it acts as a nucleophile. Rest in all the other cases, they will be acting as a base. It will abstract the acidic hydrogen, it will do the nucleophilic addition attack, and we will be getting the beta hydroxyl. We will be getting the beta keto anhydride or beta hydroxyl anhydride. When this will attack over any of the species, and it is going to be the benzaldehyde. Let's say if it is attacking over the benzaldehyde, then there is no leaving group. If there is no leaving group, then the nucleophilic addition will occur. Nucleophilic addition will occur. We will be getting the beta hydroxyl. That is, we have a benzene, yes. Here we take the benzaldehyde only. So ultimately we will be getting the beta hydroxyl. Okay, that is beta hydroxyl anhydride. And when we get this, then we can do the elimination of water. If we have one more acidic hydrogen, we can do the elimination of water. We will be, and then we do the hydrolysis. Ultimately, if we have one more alpha hydrogen, there will be the elimination of this. We will be getting the cinnamic system. CH double bond CH, and this will also be getting hydrolysis. We will be getting the cinnamic acid. Okay, by the elimination of water, by the elimination of water, we will be getting the cinnamic acid. And here also we have done the hydrolysis. We have done the hydrolysis like this, H and OH. Hydrolysis will also occur so that the cinnamic acid will form. So this is it. So this is the comparison between the Cannizaro, Aldol, Claisen and Perkins. And if you will be focusing over the the Gabriel Phthalamide, then definitely Gabriel Phthalamide is another type of reaction where we have the Phthalamide and which will be having one of the acidic hydrogen only. There we have only one of the acidic hydrogen, which is the NH bond. Okay, so many a time students gets confused between the Cannizaro, Aldol, Claisen and Perkins and what will be the product of these compounds. So here I have given you a complete idea. Okay, you can form the lines here so that you can better understand. Okay, so these are the substrates that we will be using. These are the bases or the nucleophiles they will be acting, and then after these are the products. So we will be getting after having only the one alpha hydrogen. Okay, and if they will be having two alpha hydrogen, these are going to be the products. So section wise I have given you a comparison so that you can have a clear look and try to identify, okay, what is so happening in all those reactions. Okay, so I believe this all is very clear to all of you. You guys can better understand what I have told you. Okay, and so yeah, this is it. I hope you really liked this lecture and you are able to understand all about these four reactions. So if you have done this much, you need not to put more time on this. This is it. This is very clear. Just start doing questions on the same. There are the questions given in the MS Chauhan book on the Aldol and Claisen condensation reactions, and Aldol and Cannizaro. There is a separate chapter on which the questions are given. Start doing all those questions. Okay, you will be able to. These are very important and interesting reactions. You will find many times, and definitely in the JEE paper one of the question will be asked from this part. Okay, so this is it. I believe you will enjoy it. So thank you so much. Thank you so much. Thank you. I'm not able to write it here. So this is it for you guys. Will definitely be looking forward to see you, and if you want the complete PDF of this particular session, then definitely you do ping me on the Telegram group. Okay, we do have a Telegram group and the link of the Telegram group is being mentioned in the description section of this particular video. So you go to the description box, click over the Telegram link, join the group and message me, ma'am, I want a PDF of this particular file, which whatever you have taught us today, then definitely I will share with you the file, and I will also be giving you the PDF of the question bank on the same. Okay, if you people are really interested, do let me know, then only I will put this much of efforts for you. If you are not interested, then there is no point. Okay, so this is it. Thank you so much guys. Bye bye, take care. And yes, just for a courtesy, if you really enjoyed the session, please hit like, whether it's a recorded for you or whether it's a live for you. Thank you.